Hello everyone, my name is Paula Birocchi. I am a postdoc researcher from the University of São Paulo, and this study was related to my PhD, and the title is Modeling Particle Dispersion and Sewage Pollution in a Subtropical Estuary Under Climate Change and Extreme Events. The area of study is Cananéia-Iguape Estuarine Lagoon Complex, which is a barrier island of 70 kilometers. It has two main entrances to the ocean, which is the Cananéia Southern Inlet and the Capara Northern Inlet. And the VGC, or the Valo Grande Channel, is the main channel that is flowing fresh water to the system through the Ribeira de Iguape River. Studying the transport time scales and residence time is important for coastal management programs, and quantifying estuarine and freshwater residence times is crucial for studying pollution. So, one approach is the estuarine residence time, where we release particles along all the estuary, and another approach is the freshwater residence time, where we quantify and release particles just in the river mouth and see for how long these particles stay inside the estuary. Our objective is to investigate the estuarine and freshwater residence times and the bacterial concentration and compare them under river discharge increase and decrease due to climate change and extreme events using a hydrodynamic model coupled with a particle tracking model. And our hypothesis is that such extreme events and the river discharge variability affect the residence time in the estuary, including the particle dispersion and the sewage accumulation in the estuary. Our method comprehends the Estuarine Coastal Ocean Model, the ECON, together with the Open Drift Particle Tracking Model, where we quantified the estuarine residence time and the freshwater residence time. And we compare them with the bacterial decay through the water samples collected during some campaigns in the summer and during the winter. So our results, we validated the model for the sea level, for velocities, and for the salinity. We found concentrations above the legislation in the VGC mouth, close to the river mouth, and we classified our data according to ebb or flood tide and according to spring or neap tide. And we found greater concentration during the ebb and neap tides, and these concentrations were above the legislation limit and also during the summer. So we found a decrease in the residence time in filter June scenarios where we have an increase of the rainfall, and we found an increase of residence times in September where we have decrease of rainfall. These scenarios are related to climate change scenarios of the IPCC. And we also found the shortest residence time in the storm tide of August 2016 and the longest residence time in the atmospheric blocking. One finding that is interesting is that the bacterial decay was shorter than the freshwater and the estuarine residence times, which makes the Cananéia and Guape estuary a place of bacteria sink and depth and depuration of organic matter inside the estuary. Here are some results for the climate change scenarios. And we found the longest residence time for atmospheric blocking and the shortest one for the storm tide of August 2016 due to the differences in river discharge. Here are examples of freshwater residence time and estuarine residence time for the atmospheric blocking scenario, where we found the longest residence times possible inside the estuary. So, conclusions: filter river discharge variability affects the particle accumulation and transport in the estuary. The estuary is a place of bacterial sink and depth, and this place is suffering from sewage pollution and needs to be monitored. Understanding pollutant transport time scales can help policymakers to develop strategies to maintain water quality and public health. So, We were able to test our hypothesis, and this is true. So, such extreme events and river discharge variability affect the estuary and freshwater residence times, including particle dispersion and sewage accumulation in the estuary. And we were able to quantify the residence times and bacterial concentration under climate change scenarios using modeling. Thank you very much. This is the acknowledgements, and please contact me by email, and the paper is here. Thank you.